Assalamualaikum and hi everyone. Let's continue with part 4 for the topic numeric data. In this part, we will learn about maths class and also data conversion. The maths class is in the java.lang package. It contains class methods for commonly used mathematical functions. We have used and seen some of the maths class in previous examples, such as using maths.py to get the value of pi and also using maths.power, POW. We have seen the Java API for maths class where it listed many available methods that we can use. To use the methods inside the maths class, we don't have to write the import statement because maths is already included. In this example, it used maths.max and maths.square root. What do these methods do? Let's rewrite the program to have complete values. We will look at maths.max and maths.square root separately first. We have double num x and y. Then we initialize x equal to 99 and y equal to 7. We use maths.max x, y, which will compare the value of 99 and 7. And as the method name indicates, this method will compare the two numbers to find which is the maximum number. The number that is the largest will be kept in the variable called num. And finally, variable num value will be displayed. What do you think the output will be? It will display 99.0. So why does it display 99.0, not 99? This is because if we refer to the Java API, it states there that two numbers are of type double, and it will return a double value. If we declare our variable num, x and y as int, when we do maths.power, it will return an int. Let's look at maths.square root method, where we combine it with maths.max. This can look daunting, but it really is a simple code. Maths.square root is basically taking a value and find the square root of it. Before we look at this code, let's look at a very simple example of maths.square root. Say that we have system.out.println maths.square root 4. So we want to find out what is the value of the square root, the value 4. If we run this code, we will get 2.0. So why do we get 2.0, not just 2? If we refer to the API, which I took the screenshot of it, it says method square root will return a double value. And see that in square root method, it takes in one input only. Other than using the square root method in the maths class, we can also use power method instead. We can write it as maths.power x, 0.5. It will give the same result. As shown over here, when we do maths.square root 4, that is exactly the same if we do maths.power 4, 0.5. Going back to our complicated looking code, at maths.square root, we include maths.max, and also we will do an addition. Let's break that down and write it within several lines of code. Over here we have num equal to maths.square root in parentheses maths.max x, y, and that value is added to 12.4. This is exactly the same as these three lines. So we have num equal to maths.max x, y, where the first one, it will find the maximum value using maths.max. Next, we have num equal to num plus 12.4. What it's doing is, after it has found the maximum number of x and y, it adds 12.4 to it. After that, in num equal to maths.square root num, it finds out what is the square root of the value that has been calculated before. This example is just to show that you can use and call as many methods required for any kind of calculation. Depending on your style, you can choose to make it compact by writing within one line or spreading it out into several lines. They all still refer and mean the same thing. The important part is remember for parentheses, you will start with the inner parenthesis and going outwards. If you choose to write it within one line, see that the first one it will do the max.max, then do the addition, and finally then it will do the square root. Let's look at another example. See that we have this quadratic formula. Minus b plus square root of b squared minus 4ac divided by 2a. In Java, we have to write it explicitly where multiplication is by using the asterisk sign. For b squared, since it means b times b, we can write it as that, or we can use the maths class method, which is maths.power. We can write as maths.power b, 2, which means b squared. Also, in this formula, it uses square root, so we can use maths.square root method, or we can also use maths.power, where it is to the power of 0.5. So, for this quadratic equation, there are three ways of writing it. They are slightly different in terms of using maths.square root and then using maths.power, and also instead of using maths.square root, we use maths.power, which is to the power of 0.5. All of this will give the same result, only slightly different ways of writing and the use of maths methods. Pay attention to the parentheses because that is really important that you open and close your brackets at the correct part. This table lists some of the maths class methods. Other maths methods in Java, such as exponential, log, sine, cosine, tangent, finding minimum and maximum values from two numbers, and many other methods. You can go through the Java API for the full list. In this slide, it shows the precedence of the expression we have learned in the previous part. It starts off with parentheses and then of other priority level. Data conversion. Sometimes it is convenient to convert data from one type to another. For example, in a particular situation, we may want to treat an integer as a floating point value. These conversions do not change the type of a variable or the value that is stored in it. They only convert a value as part of the computation. For example, if we have int result, meaning that the variable result should be an integer, but we have result equal to 4 times 5.12, which will result in decimal point 20.48. However, result is type int. When we try to compile it, it will give us an error because of the different types, meaning that result is int, but 4 times 5.12 is a type double. So, to make this code valid, we have to convert 4 times 5.12, which is 20.48, to an integer. Then we can compile and run the code without any error. So we can have result equal to, in parentheses, int, meaning that we are forcing 4 times 5.12 to only take the whole number without the decimal point. But the result has lost the precision due to the conversion from double to int. You can try and run this code to see the output of it. Also, we are going to learn about writing the data type, for example over here, int in parentheses when we looked at casting. There are two types of data conversion, which are widening conversions and also narrowing conversions. Widening conversions are safest because they tend to go from a small data type to a larger one. For example, short to int. Narrowing conversion can lose information because they tend to go from a large data type to a smaller one. For example, int to short. In Java, data conversions can occur in three ways. The first one is assignment conversion, Second is promotion, and thirdly is casting. What we have done in the previous example is casting from double to int. We did narrowing conversion. This slide shows widening conversions, which is from small data type to a larger data type. For example, from int to long, float, or double. And narrowing conversions, which is from a large data type to a smaller data type. For example, if we look at from double to int, long, or float. This widening or narrowing relates back to the values that each data type contains. For example, byte has the range of -128 to 127. Int, it has the range of approximately -2 billion to +2 billion. So, if we change from byte to int, we are widening it to be able to cover a larger range. If we change from int to byte, we are basically narrowing the range from the ability to contain values up to 2 billion to a maximum of 127. Let's look at the first way that data conversion can occur, which is through assignment conversion. Assignment conversion occurs when a value of one type is assigned to a variable of another. For example, if we have int dollars equal to 20, double money equal to dollars. Only widening conversions can happen via assignment. Note that the value or type of dollars did not change. What do you think is the value of money? If we do system.out.println, money is now 20.0 because it is of type double. The second data conversion is through promotion. Promotion happens automatically when operators in expressions convert their operands or numbers. For example, if we have int count equal to 12, double sum equal to 490.27. And then we have in the third line, double result equal to sum divided by count. The value of count is converted to a floating point value to perform the division calculation. So basically, we have double sum divided by int count, so we will get the result in a double. The same goes if we have int divided by a double, then the result will be in type double. The third data conversion is casting. Casting is the most powerful and dangerous technique for conversion. Both widening and narrowing conversions can be accomplished by explicitly casting a value. To cast the type is to put in parentheses in front of the value being converted. For example, if we have int total equal to 50, float result equal to float total divided by 6. This means we are casting the value total to a float. Without the cast, the fractional part of the answer would be lost. To understand about casting, let's try it in several ways. Do you think that all of this would produce the same value as the output? The first one is similar to the example before. We have int total equal to 50, float result. And then we have result equal to float, so we are casting, total divided by 6. And then we are going to display the result of it. If we run this code, it will display 8.33. What happens here is it changed the value of our total, even though we define our total as an int and it has the value of 50. So when we cast it, we are basically doing result equal to 50.0 divided by 6. So when we have float divided by int, the result will be of type float. That's why we get 8.33, not just 8. In the second one, we cast the total value and we also cast the value of 6. So this is basically 50.0 divided by 6.0. So when we do float divided by float, obviously the answer would be of type float. That's why we get 8.33. Normally, we don't have to cast both of our variables because we know from before when one of it is type float, then the answer would be in type float. So this is quite redundant. The third one is total divided by float 6. So we are casting the value 6. This is similar to the first one, but we are writing it the other way around. This means the result is equal to 50 divided by 6.0. So we will also get 8.33. Last one, which is casting the value of total divided by 6 in parentheses. What this means is total divided by 6 will be evaluated first as parentheses has the highest priority. So it basically is 50 divided by 6, which is 8. Then it changed from integer value 8 to a float value. So the final value of result is 8.0. It has lost the precision because we forced the division to be done as integers, and from integers we change it into float. That's why we get 8.0. Just to recap, the output that it shows when we do float divide by int or float divide by float is 8.333333. So remember that for float, it can show up until 7 significant digits. If we use double, it will show up until 16 significant digits. So it depends on the precision that you want your numbers to have. Explicit typecasting. Instead of relying on the promotion rules, we can make an explicit typecast by prefixing the operands with the data type using the following syntax. In parentheses, the data type followed by the expression. For example, if we write float x divided by 3, we are casting the value of x to float, then only it will divide by 3. So in that question, we are basically doing float divided by int, and we will get float as the result. In the second one, we have int, and then in parentheses, x divided by y times 3.0. So what we are doing is, we are going to do x divided by y times 3.0, and that value will result in a float or a double. And from that float or double, we cast it to become int. Implicit typecasting. When the explicit typecasting is not included in the expression, then the implicit typecasting is applied when a value is assigned to a variable. For example, if we have double x equal to 3 plus 5, this implicit assignment typecasting will promote the value of the expression to a higher precision to match the data types of the variable. 3 plus 5 is type int. Since variable x is type double, the value 8, which is type int, is promoted to 8.0 of type double before it is being assigned to the variable x. This is an example of promotion. Demotion will not occur implicitly. You need to explicitly do the typecasting for demotion. For example, if we have int x equal to 3.5, this is not allowed. To do it, we have to write int x equal to 3.5 and we cast it to int. This slide is showing the implicit and explicit typecasting. For example, for int to double, we don't need to write explicitly. So we have int x equal to 5, double y equal to x. We can write it if we want, double y equal to double x. So when we write the cast double, that means that we are doing it explicitly. However, we don't have to because this is promotion. From double to int, which is narrowing, we need to explicitly cast it. Otherwise, it will give us an error when compiling, saying that incompatible types, possible lossy conversion from double to int. If we have double x equal to 5, we have to cast it to change it to int. For example, int y equal to int x. If we try and write it as int y equal to x, that is not allowed. Let's look at this example of a class called testCasting. We have a variable of type double called number. It is initialized to 3.45. We want to cast it from double to int, so we have to explicitly do it by writing int and the number. When we do int number plus 0.5, we are doing firstly the parenthesis, which is number plus 0.5. Then from the result, we are casting it to int. So we have 3.45 plus 0.5, which is equal to 3.95. Only after we have calculated it, then only we cast it. Normally, we would expect it to give us the value of 4, because 3.95, if we round it, it should be 4, not 3. But as we are casting it, it loses the precision and only takes the whole number, which is 3. So remember that when you use casting, you need to be careful of the values that you expect. In this case, we expect to get 4, but instead we get the value 3. Casting is to cast operator in an arithmetic expression. Wrapper classes is to perform necessary type conversions, such as converting a string object to a numerical value. We have seen casting. So what exactly wrapper classes do? Let's look at some code example. See that we have string number equal to 123 in double quotes, and then we have int add equal to number plus 5. When we do our system.out.println, does it do 123 plus 5? Does it display 128 or does it display something else? When we try to compile it, it will give us an error saying incompatible types. String cannot be converted to int. So when we do 123 plus 5, it does not do the addition because of the different data types, string and int. So how can we convert a string to int? Within the integer class, there's a method called parseInt that will pass the string to integer. So the string 123 is no longer a string, but instead 123 is now a number. We write it as integer.parseInt, where integer is in capital I because we are referring to the class that is called integer. When we run this code, the output that we will get is 128, which is the addition of 123 plus 5. Other than parseInt, we can also parse it as a double. To do so, we will write double.parseDouble. The same goes if we want it as float. We will write float.parseFloat. In this slide, it shows other classes with the parse methods, similar as the previous slide. Take note that if the values that we have is not supported by the type of parse we are doing, it will give us an error. For example, if we do integer.parseInt 25.3, it will give us an error because it expects an int value. Another example, say that we have double.parseDouble AB3. That also will give us an error because we have characters other than numbers. To summarize, we have learned about maths class and looked at some of the methods that maths class has. Then we looked at the 3 types of data conversions through assignment conversion, promotion, and also casting. We have also looked at wrapper classes where we can pass, for example, string to numbers into integers or double data type.